Hi there and welcome to this senior physics video on Newton's gravitational law. Now basically we all know that Isaac Newton was probably one of the founders of the concept of gravity. He basically brought together the ideas of Copernicus and Kepler and developed ideas from Galileo with the effect of falling bodies. And from this he generated his three laws of motion, basically the law of inertia, the law of, in order to accelerate an object, you had to apply a force, and the third law, which is for every action there is an equal and opposite reaction. But one of the things that had been astounding scientists for many years is, although we've got these laws generated by Kepler, his ellipse law, his area law, and his period law, and we know that the planets are actually spinning around the sun, what is it that actually holds them in place? And it was Newton who came up with this revolutionary idea that this magical presence, or what have you, or tether, was actually an invisible force. This invisible force he basically called gravity. And from this he produced a relationship and said that every object which comes into contact with another object of a certain distance will exert a force. So at the moment, there is a force exerted between myself and the computer screen. Now, because our masses are not particularly different and our distances aren't particularly large, the force is very small. But when we start dealing with larger masses, especially masses with respect to the size of planets and the distances, the result is that we see the effects of this force. We've seen the effect of forces between large objects and movable objects. For example, when we look at the moon and the generation of the tides, the moon generates a force on the Earth. Now we don't see that force, but we do see the movable portion of the Earth, the water, the oceans, being subjected to the moon, which as a result pulls that water to generate the tides in different areas around the planet. So that force obviously can be observed. Although it's invisible, we can observe the effects of this force. So from this, he produced this relationship that basically said for any two masses, m1 and m2, the gravitational force of attraction between them, Fg, is where we get Fg will equal g, which is the gravitational constant, 6.67 times 10 to the negative 11, times the first mass times the second mass, divided by a square of the distance between them. Now, this square of the distance, or over the square of the distance, is what we call Newton's inverse square law, which basically looks at the effect over a certain amount of distance that the force happens. Now, when we're talking about distance with respect to the planet Earth, we're talking about 6,400 kilometers per se. So every time we go out 6,400 kilometers, which is one Earth radii, the result is we're going to see a decrease in the actual force which is generated on an object. Now, this can be seen in the diagram at the bottom, where we've got our two masses, we've got our distance between it, and then the relationship is the force which is generated by each mass on the other. So let's have a look at an example problem. So here we're going to determine the force of attraction between the Earth, the Moon, given that the Earth-Moon distance is 3.8 times 10 to the 8 meters. We know that the mass of the Earth is 5.98 times 10 to the 24 kilograms, and the mass of the Moon is 7.35 times 10 to the 22 kilograms. So we apply our formula, Fg equals g m1 m2 divided by d squared. So I've got my gravitational constant, 6.67 times 10 to the negative 11, and I multiply it by the two masses, 7.35 times 10 to the 22, which is the mass of the Moon, times 5.98 times 10 to the 24, which is the mass of the Earth. I then divide it by the distance between both of these, which is 3.8 times 10 to the 8, and I must square that value. As a result, the force of gravity generated is 2 times 10 to the 20 newtons. Okay, so I hope that helps you with respect to answering that sort of problem. I'm going to put up a load of other links that will allow you to either watch a video of an exemplary problem on Newton's law of gravitation, and I will also put up a worksheet that you can work through. So I hope you found that useful. Thanks for watching. I look forward to meeting you again. Bye for now.